All right, let's move on to some exponent work. So here I've reprinted the rules here, so let's go through and do this. So this is u to the 1 times u to the 2/3, and I distribute that, minus 2 over u to the 2/3. I'm just going super slow because I want you to know we need to add these exponents, correct? So when I add those, I get u to the 5/3, making common denominators here. And I'm going to subtract these exponents, and so I'm going to encourage you to always make positive exponents. So this will be 2 over u to the 1/3. All right, so multiplying this out, let me just write this out just because we're going to be multiplying things like this out a lot. So I want you to have memorized this pattern. So in case you're writing it out and foiling it. Okay, so if I take e to the 3x and square it, and so minus 2 times e to the 3x times 3 root x, and then plus 3 root x all squared. So I'm just going slow, so I make sure we do the arithmetic correctly. So these multiply, so I get e to the 6x, then I get minus 6 e to the 3x root x, and in here I would get 9x. And that's as much as we can go. All right, so the operation here is division. So let's just take a moment and even just write each as an exponent. So x to the 1/2, y cubed. I'm going to bring this y to the -1 up to the numerator as y to the 1, and then this is x to the 3/2. So again, I want to leave positive exponents, so I'm going to bring this down here. So 3/2 minus 1/2 gives me x to the 1 power. Then I'm going to add these exponents, so I get y to the 4th. All right, so another multiplying out. This will do a lot of, so I want to make sure you're very comfortable with this. So 1 over t squared squared gives me 1 over t to the 4th, plus 2 times 1 over t squared times t squared, plus t to the 4th. So this middle term here gives me just 2. All right, let's look at this one here. So e to the x squared minus 2 times e to the x 2e to the negative x plus 2e to the negative x squared. So this gives me e to the 2x. Remember, we multiply those. These two, when you multiply, you get e to the 0, so that just gives me a -4. And then this square gives me a plus 4e to the -2x. So just playing with these a lot so you're very comfortable, so there's no question. So e to the 2x squared minus 2 times e to the 2x, e to the -2x, plus e to the -2x squared. So that gives me e to the 4x minus 2, since these multiply together to give me e to the 0, which is 1, and then plus e to the -4x. All right, so something we'll be doing a lot of, so I'm just going to start introducing it now. So average velocity is change in distance over change in time. So average velocity is change in distance over change in time. Something I think you know. So s of t is a position function. So at any time t, it tells us where it's at. So if I'm asking you to find the average velocity between time 1 and time 3, I need to find its position changes. So to find s of 3, where it's at time 3, I put 3 into this function, and that's how I got 36. So s of 1, I put 1 into this function, and that's how I got 4. So this is the position at 3, this is the position at 1. So s of 3 minus s of 1 gives me the change in the distance. 3 minus 1 is the change in time, so this gives me the average velocity. All right, so let's do one together. So this is the different position function. So if I wanted to go find s of 4, so 4 to the 4th is 256, subtract 1. Oops, 256 subtract 1, so that's 255. And then s of 2 is 16, sorry about that. 16 minus 1, so that gives me 15. All right, so to find the average velocity, I'm going to be taking where it's at time 4, subtracting off where it's at time 2, dividing by the time change, which is 4 minus 2. So 255 minus 15 over 2. So that gives me 240 divided by 2. So that's 120. And I think I gave you units miles per minute. All right. So that is average velocity, something I want you to know.